In this video, we are going to talk about significant figures. Significant figures are one of the ways we can approximate our values when we are doing computations in physics. And so, I want to start by giving a brief introduction to what approximations are. Approximations are scientific ways of shortening lengthy numbers when we are doing computations. For example, if you are dealing with pi, we know that pi is a recurring decimal. If we find the value of pi on our calculators, we are going to get 3.14159264. Even this is what the calculator can give us. We can get more digits in the value of pi. It never ends. So if you are working and you have to work with pi and you have to write it in digits, you don't have to write all the digits your calculator will give you, and even those that your calculator cannot give you. This is why it becomes necessary to do approximations in physics. So approximations become very necessary when we are doing computations of lengthy numbers. What we have to take note here is that approximations do not drastically change the value of the numbers. Your answer that you get should be close to the original figure that you are given. Alright, having said that, let us go into what significant figures are. Significant figures are the number of digits in a value or measurement necessary to decide the accuracy of the value or measurement. When dealing with significant figures, there are two simple rules that we have to take into account, and these rules talk about zeros. There are two kinds of zeros that we will deal with in significant figures, that are non-zero numbers and zero numbers. And so let's start with non-zero numbers, and that gives us the first rule. It says that all non-zero numbers are considered to be significant. So what is a non-zero number? A non-zero number is a number which doesn't have the digit 0 in it. So for example, 4372 or 4372 is a non-zero number because all the digits are not zero. In this case, each of the 4 digits are significant. So 4372 has 4 significant figures. Alright, let's talk about the second rule. Zeros in a number could be significant or not based on the position of the zeros. In this case, we are going to talk about 3 types of zeros with regards to their position. The first one is called the leading zeros. The second one is called the captive zeros. And the third one is called the trailing zeros. So let's deal with leading zeros. Leading zeros are the zeros that precede non-zero digits in a number. And this especially occurs in decimal numbers. So for example, if you have 0.02, there is only one significant figure in this number, which is the 2, because the zeros are leading zeros. They precede the non-zero digit, which is the 2. Let's talk about the second type of zero, which is captive zeros. As the name implies, captive zeros are the zeros that are found in between digits in a number, and captive zeros are said to be significant. So for example, if we have 101.205, we have 2 captive zeros and all of them are significant. In this case, it makes the numeral 101.205 to have 6 significant figures. In other words, all the digits here are significant. Now let's go to the third type of zero. They are called trailing zeros. and trailing zeros, as the name implies, are the zeros that come at the end of numbers. When we come to trailing zeros, there are two things that we have to take into account. We have to take into account whether the number in question is a whole number or is a decimal number. Trailing zeros in whole numbers are non-significant, but trailing zeros in decimal numbers are significant. So for example, if you have 100, the two trailing zeros are non-significant. In this case, there will be only one significant figure in this number. But if I have 1.00, though there are two trailing zeros, because they are found in the decimal numeral, they are counted as significant. So the numeral will have three significant figures. So this is the basic understanding we have to deal with significant figures. Having had that, let's have these 5 numbers and let's determine the number of significant figures in them. 1. 30004. 2. 4300. 3. 2.800. 4. 0.006. 5. 0.0000230. Alright, so let's get to the first one. What do you think is the number of significant figures in this number? You can pause the video and work it out. In fact, you can pause the video and work it out for all the 5 before we continue. Alright, though there are zeros in the first number, all the zeros are captive zeros, and so they are counted as significant. In this case, we will have 5 significant figures in the first number. When it comes to the second number, 4300, because the number does not have any decimal point in it, and there are 2 trailing zeros, the 2 trailing zeros become non-significant. In this case, only the 4 and the 3 become significant, and so there are 2 significant figures in this number. The third one, 2.800, there are 4 significant figures in this number because the 2 trailing zeros would also be significant because they are found in a decimal numeral. Number 4, we would have only 1 significant figure because the zeros are all leading zeros, and like we have said already, leading zeros are non-significant, so only the 6 become significant. The fifth one, we are going to have 3 significant figures because the 4 leading zeros are non-significant. We have 2, 3, and a 0 are significant, and though the last 0 is trailing, because it is found in the decimal numeral, it is considered to be significant. Now let's move on and talk about more ideas in significant figures. I'm going to give you a number of figures and I'm going to ask you to write them in a particular number of significant figures. Alright, so the first one is 0.000411517. We are to write this in 2 significant figures. Before we go any further, I want to remind you that when we are doing significant figures, we are doing approximations, and we are not supposed to alter the value of the original figure so much. In this case, the number given is 0.000411517. This number is so small, it is not even up to 1, and so your answer must still be in the form of 0.0004. Then the rest will continue. Other than that, your answer will be wrong. So our task here is to identify the first 2 significant figures in the number, because you have been asked to write it in 2 significant figures. So the leading zeros are not significant, so you are not going to count them. So the first will be 4 and the second will be 1. In other words, 4 and 1 will be two significant figures that we want. In this case, the rest are not significant, so we are not going to write them. But what we have to do is that we have to look at the digits that follows immediately after the 1. If it is 5 or more, we have to add 1 to the 1 to make it 2. And since it is 5, we are going to add 1 to the 1 to make it 2. So our answer is going to be 0.00042. And this is in two significant figures. And you see that we have not altered the figure so much. Now B, 0.0528073. We have to write this in three significant figures. So we are supposed to identify the first three significant figures, which are 5, 2, and 8. Now we have to consider the digits that follows immediately after the 8. Since it is 0, we cannot do anything about it, and so we are going to have 0.0528 as our answer. The third one is 4307.01507, and we have to write this in 6 significant figures. So let's identify the first 6 significant figures. That is 4, 3, 0, 7, 0, and 1. But since the digit that immediately comes after the 1 is 5, we will add 1 to the 1 to become 2. So our answer is going to be 4307.02. Now let's write the same number in one significant figure. So the first digit, which is 4, is what we are interested in. What do you think we are going to do? So let's write the 4 and consider the digits that follows after the 4. It is 3, so we can't add 1 to the 4, it becomes 4. But we can't leave our answer like 4, because if you consider the figure given, it is around 4,307, and 4 is so drastic a change. And so what we are going to do is that we are going to turn the 3 and 7 into zeros. So we are going to have 4000. The question is, what about the 0.01504? We cannot use them because we have learned that immediately you bring a decimal point, all the digits that follow after the decimal point are significant, whether they are zeros or non-zeros. And so we are going to get 4,000, and it is close to the figure 4,307. There is no significant change. Let's take the next one, 3850390. We have to write this in 3 significant figures. So let's consider the first 3 significant figures, which are 3, 8, and 5. So the rest of the figures, 0, 3, 9, 0, you have to convert all of them to zeros. So you are going to get 8350000 as our answer, because we know that trailing zeros are not significant. So there will be only 3 significant figures in our answer, and it doesn't change the original figure so much. Now let's deal with our last one for this session. That is 3012000. Let's write this in 4 significant figures. I want you to pause the video, write your answer before we continue. Let's identify the first 4 significant figures in the number. These are 3, 0, 1, and 2. The rest, the 3 zeros, are non-significant, but we cannot write only the 3, 0, 1, and 2 as our answer. If we write it like that, it means we have drastically changed the number. Since the 3 zeros are already non-significant, they are trailing, we can just add them. It's just like turning other digits into zeros to make them non-significant. So the answer is going to be the same as the question, 3012000, and this is in 4 significant figures. Now let's talk about the last thing before we end this tutorial, and that is operations on significant figures. In mathematics and physics, we do computations, and the computations are mostly addition, multiplication, division, and subtraction. So if you are given two numbers to add and they are in two different significant figures, what are you supposed to write as your final answer? Here, the rule is simple. If you are performing a computation on two or more numbers in different significant figures, always identify the number with the least number of significant figures and leave your answer in that significant figure. In other words, leave your answers in the least significant figures as given in the question. So let's have 4 of such examples and see. Number 1, let us add the following numbers: 4.328 plus 13.0 plus 5.45. When we add them, we are going to get 22.778. The question is our answer correct? Our answer is not correct. For it to be correct, we have to leave it in the least number of significant figures. And the least number of significant figures in this question is 3. And so our final answer is going to be 22.8, which is in 3 significant figures. Now let's do a subtraction. 6.357 minus 2.47. When you subtract, we are going to get 3.887. But the least number of significant figures in the question is 3, which is the 2.47. And so our answer must also be in 3 significant figures. In this case, we are going to get 3.89. Let's do a multiplication. 5.64 multiplied by 12.458. We are going to get 70.26312. Our answer is too lengthy, even more than the number of significant figures in the question given. Now the least number of significant figures is 3. So let's write our answer in 3 significant figures. We are going to get 70.3. Let's take a division. 464.6895 divided by 12.145. We are going to get 38.226179498. Too long. We can't write all. So the least number of significant figures in the question is 5, which is the 12.145. So our answer must also be in 5 significant figures, and that is going to be 38.226. Alright, this is where we bring our lesson on significant figures to an end. I am sure you have enjoyed this lesson. If that's the case, like this video, share this video, and subscribe to our channel. Thank you so much.